Welcome to lesson number 3. We're talking about piecewise functions today. So a piecewise function is just a function that has restrictions. And with those restrictions, individual expressions can be evaluated. We'll get into exactly what that means in a moment. But this is what a piecewise function usually looks like. Right? You have the function that's going to be evaluated, and then you're going to have certain function operations that are going to happen here. Right, maybe it'll be like x plus 2 or something like that. Okay, and then it's going to say words like for a restriction. Maybe x is going to be positives. Maybe x has to be bigger than 5. Okay, but they use different words, right? For, if, and when. So you're going to see an expression and then a restriction. Okay, so let's look at an example of a piecewise function, the way that they're written out. Okay, here we see this piecewise function f of x, and we're going to be using this part of the function if x is greater than or equal to 2. We're going to use this piece of the function if x is less than 2. So now they have all these values that we're going to evaluate. Okay, so here's what happens. We look at, for example, a, f of negative 2. We look at our function. Negative 2 is definitely less than or equal to positive 2, so we're going to want to use this top function. So we have at negative 2, we have negative 2 times negative 2 minus 1. That's the function that we're using. That's the negative 2 that we substitute for x. Okay, negative 2 times negative 2 is 4 minus 1. That gives us 3. Okay, and we continue to do this in the same fashion, right? We look at the next value, 0. 0 is less than 2. We're going to plug it into this function. So we've got negative 2 times 0 minus 1. Let's see, negative 2 times 0 is 0 minus 1. That gives us negative 1 for a solution. Then we get to this example where it says f of 2. Well, here our restriction says that we're allowed to use 2. So we're still using this top function. So here we have negative 2 times 2 minus 1. Negative 2 times 2 is negative 4. And if we subtract 1 from there, we get negative 5. Now we start looking at some values that are above positive 2. Right? 4 is greater than 2. So we're not using this one anymore. We're going to be using this function, or this part of the function, because x, what we're evaluating, is bigger than 2. So we've got opposite of x plus 4 is what that function calls for. So negative 4 plus 4 equals 0. And again, f of 10. 10 is greater than 2, so we're using this top function. So that's opposite of x plus 4. Negative 10 plus 4 is negative 6. Okay, that's the basics of how piecewise functions work. You have restrictions, you have parts of the function that you're going to use depending on those restrictions. So let's check out another example. Okay, we have this piecewise function. This time it's a little bit more advanced, right? This time we have x squared, and this time we have absolute value of x, and our restrictions have changed. Here we're saying anything less than negative 4, and here it's anything equal to or greater. So we got to make sure that we're using the right function. So this first problem is negative 10. Negative 10 is less than negative 4, so we're using that top expression. So we have 2 times negative 10 squared. Negative 10 squared would be 100. Times negative 2, we get negative 200 for our solution here. Negative 6, again, we fit into this restriction. So we have negative 2 times negative 6 squared. That's negative 2 times positive 36, which equals negative 72. Problem C, it gives us negative 4. Negative 4 doesn't fit in this topic restriction anymore because this says strictly less than. here is where we're allowed to use -4. So now we're going to have to use the absolute value function. So we have opposite of the absolute value of -4. Well, the absolute value of -4 is 4, so they're looking for the opposite of 4, which is -4. These other two are going to fit into this same restriction. So we're going to continue using this function from here. Opposite of absolute value of -1, that would be the opposite of +1, which is -1. Here we have 12, so we want the opposite of the absolute value of 12. Alright, the opposite of 12 is -12. Alright. That one's blank. Alright, so I've got a couple of problems for you to try out. If you want to write these down, try them out on your own. Pause the video, see what you get for answers, and then compare. I'll give you a moment to try that on your own. Alright, let's check out how you did with these. So remember, you're looking for the restriction first. We'll notice that -1 is going to fit into our top part of the function, so we're going to use that top part first. So we have -1 squared minus 3. -1 squared is 1 minus 3 is going to give us -2. We're going to continue with our top function for this one. We have 2 squared minus 3. That would be 4 minus 3, which is +1. We're going to continue again with this top function because it says equal to 5, and that's what we have here. So we have 5 squared minus 3. 5 squared is 25. Minus 3 leaves us with 22. Here's where we start to switch to the bottom function. All these values are greater than 5. That's the restriction. So here we have 8 divided by 2. That gives us 4. And now we have 24 divided by 2. Again, for this top function, that leaves us with 12. So hopefully you came up with those same solutions for those piecewise functions. Now we get into some slightly different piecewise functions. It's the same concept, right? We have restrictions and different functions or pieces of functions for those restrictions. But sometimes we have more than 2 restrictions. Sometimes we have 3. Other times you can have as many as you want. Depends on how detailed you want your piecewise function to be. Okay, so we're going to do the same exact thing. We're just going to check to see where these values fit inside of these restrictions, and then we'll use the function piece that they give us. Real quick, you might notice there's no x associated with this. So that means if I have a value that fits into this restriction, my solution is going to be -4. There's nothing else I'm going to do to it. So let's check this out. Our first example, they give us -5. Well, -5 fits into this category, right? It's less than or equal to -2. So if I evaluate -5, no matter what, the piecewise function is going to spit out -4. The second problem, -2, we're still fitting into that category, right? It's inside of that restriction. So when I evaluate at -2, again, the function spits out -4. There's nothing else happening. Now we have 0. 0 fits into the middle function, right? It's between -2 and 2. So here we have 0 minus 2, which is -2. 2, we would think, hey, look, there's 2, but notice this is less than 2. We don't want to include 2. Now we're jumping to this bottom function. This includes 2. So we have -2 times 2 plus 4. Remember, we're using this top function. -2 times 2 is -4 plus 4 gives us 0. 3 also fits into this bottom category. So 2 times 3 plus 4, that's -6 plus 4, which is -2. And lastly, 4 fits into this bottom category. So we have -2 times 4 plus 4. That would be -8 plus 4, which is -4. Okay, so we're going to try one more on your own. Here it is. Okay, take a second to pause the video, try them out on your own, and then see what you can come up with for solution. Alright, let's check this out. So -2 is going to fit into our top category. So we have the absolute value of -2 minus 3. That's the absolute value of -5, which is +5. 0 fits into that same category. So 0 minus 3 would be the absolute value of -3, which is +3. 1 now fits into our middle category because it's including 1. So we want 1 minus 1 squared. That gives us 0 squared, which is 0. Our 4 fits into that same category. So 4 minus 1 squared, that's just 3 squared, which is 9. Then our last two, we're going to notice both of these fit into our third category. They're both greater than 5. So we want to do the square root here of 9, which is 3. And the square root of 36, here that's going to give us 6. Alright, that's not it for piecewise functions though. We can also graph piecewise functions. Okay, I have a little bit of a note in red here for you. My idea or my suggestion is that you might want to figure out where your boundaries are, right? If you see strictly less than or strictly greater than, we want to figure out what value we would be approaching so that we know where we want to draw our graph to. We're not going to include that point, and hopefully you remember from Algebra 2 that if you're not including a point, you use an open circle. So we're going to have an open circle and closed circle at some point on our graph to show where the piecewise function approaches. Okay, and you'll notice I also have a little bit of a note how we can do that easily. Okay, we're going to identify the places where the function should change on the plane first before we even graph. Okay, so what do I mean by that? Well, let's look at what our function says. Our restrictions give us 2 as our changing point, right? This is where we include 2. This is where we don't include 2. That's where things change. So I'm going to find 2 on my coordinate plane. Right now I have it in purple. Okay. Let's see. Maybe I have a highlighter to make that a little bit clearer. Let's do gold. Let's highlight that in gold. Okay. So we have our restriction. What we're going to do now is we're just going to look at what these functions look like to that point. Okay. This says anything less than 2. So that means from here this way I want the function to look like this. So I need to graph this real quick first, and then I'm going to erase everything off of this side. Okay. Well, this is an easy one to graph, right? We start at our y-intercept of -5, so we're down here. Let's see, 1, 2, 3, 4, 5. And it gives us slope of up 1 over 2, so up 1 over 2. I'm going to include this point because I'm including 2. So that point gets included. I can't go any further, so I have to continue this way on our graph. Okay, so that would be down 1 over 2. Down 1 over 2. Okay, so that's what that piece of the piecewise function looks like. As far as this x squared, I want to evaluate at 2 to figure out where it would be if we included it. So if I was to use 2 and square it, we would get 4. So at 2, I would get 4 out. But I can't technically include that point, so I'm going to leave it as an open circle. When I start evaluating the next values, though, I'm going to continue with that, and I can include them now. So when I evaluate 3, we get 9, so I'm going to include 9. If we evaluated 4, we get 16. That's going to be way off of our graph, but we can see that it's going in that direction. So here you have your graph of that particular piecewise function. We included the 2 here because it's included anything less than 2. We didn't include the 2 here because this says not including 2. So I have one more of those for you to try on your own. I've given you a pretty easy one to work with. See how you do, pause the video, and then check it out with me after. Alright, let's see how you did with this. So I'm going to highlight 0, right, because that's where everything changes. So let's highlight 0. Okay. Anything less than 0, we want to look like 2x minus 1. So our y-intercept up 2 over 1. And this, unfortunately, is all the negatives. So I'm going to be going down 2 over 1, starting at negative 1. But don't want to include that point. So it's going to be an open circle at negative 1. So here we go. Here's my open circle. And for the rest of this, it's down 2 over 1. Down 2 over 1. Down 2 over 1. Okay, so that's, oops, I missed just a little bit. That happens sometimes. Down 2 over 1. So we're right here. Okay, that's what we want. As far as this particular piece, right, including 0, if I plug in 0 into this function, we get 3. So I want to start at 3. And I'm including that particular point because it's including 0. So when we evaluated, we got 3. We include that point. And from here, it's just going to be up 1 over 1. So up 1 over 1, up 1 over 1. Right? It's just going to go directly this way. And that's what your piecewise function graph will look like. Ignore these little points. I made a mistake. We're looking at this line right here. Well, that's it for piecewise functions, both evaluating and graphing. I think the trickiest part is making sure that you identify where your function changes place, right? We did that by just quickly sketching a line, figuring out what values we don't want to include and which values we do want to include, and then just graph it. Pretty easy to do. Any questions, you can leave comments, and I will see what I can do to answer them, or we can talk about it in class.